Okay, so I'm sitting now with Andrew, and this is assignment 4, and
we're going to redo part 1, basically.
we're going to redo part 1.
Because there was a few errors that were in the previous video.
Yeah, so we're just going to redo it. Same thing, drag what you downloaded on ClickUp into Workbench to get a geometry, and then double click to open SpaceClaim. Okay, so SpaceClaim is open, but another way Andrew highlighted you can do geometry is under component systems. You can drag geometry and then add it by right clicking.
Yeah, you right click and import the file that he downloaded.
Okay, cool. So this part's pretty basic. It's in the document what he wants you to do. Just have a look what measurements he uses, but I'm just going to do it how I like to do it. I just use the offset tool, and when you click on this line, it's highlighting that specific plane, so the plane that line is in. So you click there to get an offset, and it's 45 mils. And then if you click away, you can see it's only drawn one line, and that's the pre-existing sketch. So you need to make a whole complete closed sketch so you can pull it. So you just click back and you offset backwards from your original line. So that's how I did that. Then closing the sketch, you just use 2 lines. Join the dots. Okay, now you've got that sketch.
Now we got a 3D.
3D pull, and you pull this. I hold the mouse key down whilst I'm pulling and enter 20. Enter, and then that's how much you wanted to pull it. And then he gave this a thickness of 10. This mid surface. So I'm just going to click pull tool, click on the surface anywhere, and drag inwards. And you can see it's giving a measurement from the mid plane to however far you're dragging. So that was a 10 more. Enter. So then it gives it that.
That's sorted. Now we want to cut it.
Yeah, this video, last video, I merged these two, but in the class today he said don't do that.
Yeah.
Yeah. So I'm not going to do it this time.
So now we draw the planes.
Normally can get it right, but not this time. Okay, so now he wants us to cut it, so we're going to go into planes, click on the coordinate system, and it draws all 3. Move out of plane and just delete the 2 you don't want, so those 2, and you're left with that plane. Then I'm going to go to split body. Now we've got 3 bodies to split. First is this one about the plane, second one about the plane, and then finally third one about the plane. So you just click the volume and then click the plane
that you want to cut with.
Yeah, the hacksaw. Okay, so now comes the sharing topology part. Now you need to be aware, if something is a part of the pressure vessel, you want it to be in the same tree. So the pressure vessel's got its tree, support 1's got its tree, and support 2 has its tree. Now what you've drawn now is all up here, and it's not in the vessel tree. So what you need to do is just click by holding Control, select all those volumes, and then move them into the vessel tree. And then yeah, everything that's a part of the vessel is now in the vessel tree, and that's if you don't do that, it becomes a problem when you move into mechanical. You'll have very weird contact regions, and the analysis doesn't really work out properly. So now we're just going to share.
And this is the last step of SpaceClaim. Just share the topology of all 3, vessels, supports, and supports.
Okay, yeah, that's it.
Cool.
Yeah, that's it. Cool. I'm just going to save it, so make the SpaceClaim format. So not that XT format, the actual SpaceClaim format. So I'm just going to close this, open this, and we're going to begin now with the steady state thermal analysis. Okay, then now we're going to double click on model to open mechanical.
Are you going to put it on YouTube immediately?
Yeah, so now we are in mechanical, and we're just going to start off on the top of the list with the geometry. Got some question marks. and if you click on it, it highlights what it wants from you, and that's just thickness. So I'm just going to select all of them. Ooh,
and make them 10.
you need to change to 10 millimeters. Make sure you use the right unit. 10. Okay, so now we got ticks in geometry. The next thing I want to do, because it's
is the meshing. Actually, check the connections first. So we're going to go and check the connections. The folder that he gave us have contact. He's done the selections for us, but as you can see, he said in the document that he wants what's it? No separation. There we go. So we've got to go and change both of those to no separation. If you don't do this, it ends up looking like symmetrical, the deformation, and that's a problem we were getting.
Yeah, so if you watch the last video, I asked if you know what the issue is.
Yeah.
It's because the contacts he gave us in the file were wrong. So
yes, well, they were bonded and not no separation. So here as well, we want to be changing, go to program controlled, and we want to change it to try something, and it should show up on the right there.
Getting no colors.
I don't know why there's no colors.
Oh, there we go.
There we go. Bottom. And that looks right. And then on this one, do the same thing.
Bottom. This is just the orientation of the bond.
Is there color on this one? Yes.
Yeah.
Okay. Cool.
Yeah, so that is
now
right.
you got to just change the surfaces using contact shell face. So now that the contacts are done, the next step I think is the meshing. So we're going to go to mesh, insert, method, and we select the geometry for the mesh, and we're going to select basically
just the pressure vessel.
The bodies of just the pressure vessel. Yeah.
Not the neck.
Not the neck,
not
yes.
the supports.
And then we go to automatic and change it to sweep. This option will only come up if you've selected a section that can be swept.
So
you won't see the option if it can't be swept. Next one is to go to SRC target selection, automatic thin, and then element option solid to solid shell. And with those, you don't have to click the little arrow down. You can double click to change. Just double click there and double click again. Yeah, just as a quick thing. Then the next step,
I'm going to do symmetry.
Okay, so we go to model, insert, symmetry, and you're going to insert two symmetries.
So the first one we're going to do is I'm just going to do the pressure vessel. You have to tell it, because you split it, you want to tell the program where to generate the symmetry. So I'm just going to isolate, suppress.
So we're first going to do symmetry on the actual vessel, and then the second symmetry we'll do on the supports.
So
cool. So we click the Z axis to get it aligned there, and you want to do symmetry on faces. So you want face to be selected.
On the box.
And a box selection, and you drag it on the faces, and check that it's got all the faces. Yeah, that looks good.
Actually, I need it.
And then you say
symmetry region.
Yes, you need to say symmetry region, and it's chosen the faces, which is perfect. 22 faces, and that's as far as I know. That's all we need to do. Okay, apply.
Actually, hang on. Symmetry normal, x-axis. Yeah. Okay, so the normal to that face.
Yes, you need to choose the direction as well. No. Then we're going to import another. We're going to unsuppress and suppress the vessel.
Suppress body.
And then we go to model again and insert symmetry again. No. You do that. Yeah, you can do that as well. Then symmetry region 2, we're going to be doing edges this time and not faces. And you want to select the edges, and it should be 6 as far as I know.
10 edges.
10 edges, sorry.
Edges. And the normal is still, it's
and
right.
in the right direction, x-axis, and that looks correct.
Then unsuppress that.
Yeah. Cool. So now you've got your symmetry. So this model here that you can see is half a view, and what symmetry basically does is it allows you to work with half and give results on the total object. Okay, so
now going on to the steady state thermal, I'm just going to read through the document so I don't miss anything this time. I'll raise a few issues that were brought up
by people
on the last video. So yeah, first thing you're going to do is set the initial, which was 25 degrees Celsius. Okay.
Just make sure with your units, every single time you're inserting things, make sure between millimeters, degrees Celsius, Kelvin, newtons, megapascals, all of that.
So I've only ever used the top, this one and this one. Alternate between these and then Kelvin and Celsius.
Yeah.
You just have to click to see what you want.
Yeah.
So the next thing, you're going to insert a temperature on the inside of the pressure vessel. Select faces and just holds on box select still. Single select. Make sure you don't go too far and select these edges, otherwise it will change the results, I'd imagine. There.
And the inside there, and you just got to make sure that you get these underneath these little circles as well.
Because it's still within the pressure vessel.
Cool.
So now we go back to X, so back out, and it looks like we've got everything.
And we apply.
And it's 90 degrees Celsius.
Yes.
Okay. Okay, we jumped a step. We've added symmetry step 2. Step 3, apply a convection boundary. Okay. To the stand and the pressure vessel. So what I'll do is you right click, insert convection. Same deal, you select the faces. On the pressure vessel, bear in mind, don't select the supports because they're different bodies. So select one body, do the convection for that. Select the supports, do the convections for that. Do them separately because they're separate bodies.
And you also got to do the neck because
we insert the temperature.
Yeah, you don't have to do the top face because that doesn't really matter.
Well, no, we just stick with the neck.
Cool.
Because it won't do a proper convection. Now, one thing someone raised for the last video was they gave us the
value in 50 watts per meter squared Kelvin.
Yeah.
So here we're going to change it to watts per meter squared Celsius, and then you change it to Kelvin.
It actually makes...
Yeah, I don't think it makes a difference, but do it just for yes, just because.
Yeah. So if you go back to Celsius, it actually remains the same. So it's the same thing. The external temperature, you need these units. The external temperature is 20 degrees Celsius.
Cool.
Okay, so that's the pressure vessel. So now we're going to have to insert a convection for the supports. Now what I'll do is I will suppress the vessel so you get the supports.
And this is so we can select the supports.
So I'm going to go to the body or face? Face?
Yeah.
Faces.
You did faces, so.
Yeah, so I'm just going to face, box select, everything. Okay, I need this open.
Convection 2, apply.
Same value, yeah.
And we use 50 watts per meter squared Celsius or Kelvin.
And then 20 degrees Celsius external temperature, and we will unsuppress the body. Okay, next we want to now insert a results field. So you can right click, insert thermal temperature on solution, and I'm just going to generate mesh to see if I got no errors there. Okay.
Cool, so that looks good. Mesh is ticked.
Still on sweep. And then
so one of the other things that he said to do is when we export the calculated temperature field to a text file, we go to Tools.
Now let's just get the temperature. There we go.
We go to Tools, Options, and then you go down to Export. And we want to be changing include node locations to yes, so double click. and include node numbers to no. So double click and press OK.
Yeah, okay, that's exactly it. And then now you can right click
and say export and export text file.
And it should open up in Excel.
Yeah,
it should be openable by Excel. Okay, so that's everything so far for the thermal part
side
of the
things,
work.
yeah.
So let's go back to SpaceClaim, not SpaceClaim Workbench, and
put in steady structural
on solution.
static on solution. Yeah.
I don't think it actually matters, but I'll always drag it on solution.
But do it on solution, yeah.
Let me just check if it's open up in mechanical. Yeah, there it is.
Okay, so now we're going to apply a bunch of things
so
according to what he's given.
So we'll just start off with the document. So point number 5, insert standard earth gravity, insert standard earth gravity.
Correct direction is negative y.
Negative y, yeah. And that is right.
Perfect. Then hydrostatic pressure.
So we're going to go insert hydrostatic pressure. I'm going to select faces. I'm going to select all salon box select. Single select, holding down control. Select everything.
Inside.
Include these.
And those two sneaky faces.
And those two sneaky little buggers. Just now.
Cool.
Got everything. And we click apply.
Then we're going to give a fluid density of water.
I'm just going to stick with 997. Yeah, it's more accurate. This is the right units.
And just, yeah, kilograms per meters cubed is perfect.
And we're going to go to components just by double clicking.
We're going to choose in the Y direction.
It's 9.81. That's just the gravity.
Yeah.
And then
meters per second
the free
squared.
surface location is the top point of the hydrostatic fluid, which is the top of the neck, and we work that out to be 0.91 meters.
And remember that when you inserting these values, if you type in the numbers and it goes back to 0 or it doesn't do it, then use a comma instead of a point on your. I found that comes up often.
Okay, so the next thing is adding loads to the nozzle. So we're going to go, the first one is a remote force, so we're going to go here to remote force. This was a mistake I made in the last video. I clicked on force. It needs to be remote force.
This we're going to apply to the total top face, so you've got to include all 4 of those.
Probably should zoom in more.
Yeah. Then the magnitude of that is 500 newtons or 0.5 kilonewtons.
There's something we've left out. When it comes to applying forces to a free surface like this, I don't know where they said it. They want us to make another coordinate system at the point of the force, because when the symmetry occurs, you want a coordinate system that's in the middle of the symmetry. So because the force is going to revolve around this other part that doesn't really exist here, you need a coordinate system there at that point. Okay, so let's just backtrack a little bit. Coordinate systems, insert
coordinate system. Then we're going to choose where we want it.
We're going to, it's not geometry, it's
the other one, global.
It's relative to the global coordinate system,
0.91
again, yep,
comma 91,
and you can see it shifts it up there.
Cool.
So now we got it's just called coordinate system.
And you go to back to remote force and you say coordinate system.
I'm just gonna make all of these 0 so that the force itself is acting
at that point,
the coordinate system. Now components, and they wanted it Z direction.
Z direction 0.5 kilonewtons or 500 newtons. Yeah.
And you can see it's right. It's applied the force at that surface.
Yeah.
Something
else to do is the pressure inside the vessel.
Have we skipped it?
Have you done that?
Yeah, we skipped it. That's it's 0.6.
Yes. So 0.6 is in the document. Says internal pressure of 1 megapascal, so we're going to go pressure and we're going to choose all the faces inside.
We're assuming that the lid is here, by saying the pressure goes all the way up the neck.
Now just zoom in.
Yeah, not so tedious. Oh, I didn't hold
Okay,
control.
hold in control when you do this.
Yeah, lol. Okay, so we got everything.
Sweet.
Right.
Apply, and then we're going to give a magnitude of 1 megapascal. Make sure it's in megapascal.
Just make sure it's in the right direction.
And the arrow will show you that looks right. Internal.
I hate that little shuffle I have.
One way to do.
So you can see the arrows pointing outward, which is correct. Okay, back to the forces. The one they want a moment as well. So just right click, insert moments. And we are now on
doing
that
it on the
face
face as well. And the magnitude is also 500 newtons
per meter.
per meter.
And it's an X, eh? Yeah, it's an X.
So just change the units.
Oh, yeah. That's fine.
And that X is about the X-axis.
So you can see here's X.
The red is the X-axis, and
it's rotating about.
Yeah, which is correct.
Yeah. What's next? Oh yeah, it is. There is no separation. Okay.
Cool. So we've changed the connections, like it says in the document.
And now point number 10 is no separation of contacts.
Now we're going to include solutions, as far as I know.
Yeah. So we need to.
Now we go to solutions, insert.
No, you need to fix this first.
Okay.
So in thermal, you've applied a temperature to the inside of the pressure vessel, and not much is happening on the support. Nothing's happening on the supports actually, just despite cooling. So that's why there's a question mark here, because I don't know if it's a relevancy thing. I'm not sure. But what you have to do is just select the pressure vessel bodies, not the support structure. Just those, and click apply, and then you get a tick. So that's how you get rid of the question mark and that. Yeah, so now we're on to solution.
So right click, insert total deformation.
Deformation total.
And we're going to put a von Mises stress as well. Von Mises stress.
Stress, von Mises. I think that's everything, yeah?
Now let's press solve.
If it does, should be quick. Okay, in the requirements they want calculated temperature field.
Yes.
That's this.
So
okay.
when you click temperature under solution of steady state thermal, you're going to get this, and you can change, if you don't want the mesh on it, you can change it by saying no wireframe, and that'll give you a nice smooth diagram. Then something we forgot when before we inserted the solutions is we didn't do a fixed support. So we're going to do fixed support on the bottom.
Hold control. Faces, control, apply. Are we going to run it again now? Okay, cool. So the simulation ran after adding the fixed support, and this is very much what he got in.
If you look at the document, yeah, it looks very similar. You can change what it looks like by clicking on the scale, yeah, true scale, and clicking on the scale and pressing minus to make it look as much like his as possible.
I think his was standard as.
Was it?
Somewhere
yeah,
about here.
something like that, yeah. I know there was red on the one side, so that's looking good.
And then equivalent stress, same deal. You zoom in and out.
I'm not sure what his looked like.
And then his screenshots, he zoomed up.
That's on a different. That's on the section.
Yeah, that's part 2.
So part 2, we basically cut this section out. So you draw on here, you cut it, and you delete the rest of it, like you did in class today, and then you do an analysis on just this little piece here.
Okay, cool. So hopefully that solved the issues.
All the issues and the mistakes from the last video.
And it's all right, I hope. Cool.